Assalamu alaikum wa rahmatullahi wa barakatuh. This is the sixth video of chapter 11, Work and Energy. At the end of this video, you're going to be able to calculate the gravitational potential energy. We have mentioned in the previous video that an object that possesses kinetic energy can do work on another object. For example, a moving hammer driving a nail into a wall. Now, we shall introduce another form of energy. This energy is called potential energy. The energy stored in a system due to the interaction between its constituents is called potential energy. Potential energy depends on the arrangements of the constituents of the system, such as position, shape, or state. It is called so because it is stored. There are many forms of potential energy, such as gravitational potential energy, nuclear potential energy, elastic, chemical, magnetic, and electric potential energy. In this chapter, we will discuss the gravitational potential energy only. To understand this form of energy, let's think of this situation. If we now raise the ball to a certain height and release it, what may happen? It starts falling downwards from the height h above ground. The ball, which was initially at rest, gains speed, that is, it gains kinetic energy when we let it go. In other words, it starts with zero kinetic energy and then gain some kinetic energy. Where does this kinetic energy come from? Remember that we said before that energy is neither created nor destroyed. It is transformed from one form into another. Then there was some energy stored somewhere and transformed into kinetic energy. Where do you think this energy is stored? In the ball or in the system ball Earth? As this energy cannot exist without gravity, so the ball cannot fall and stay close to the hand of the person. So this energy cannot be stored in the ball alone, but in the system ball Earth. This energy, which is stored in the system ball Earth, is called gravitational potential energy. This stored energy is called so because it is due to the gravitational interaction between the object and the Earth. The gravitational potential energy of a body depends on the following two factors: the weight of the body, as when an object falls toward the Earth exerts a gravitational force mg on the object, with the direction of the force being the same as the direction of the object's motion. The gravitational force does work on the object and thereby increase the object's kinetic energy. The other factor is the height above a given reference. Let's have a closer look. The weight of the body. What do we mean by that? If we are on Earth of a gravitational acceleration g and we release a stone from rest directly above a nail in a board lying on the ground, when the stone is released, it falls toward the ground, gaining some speed and therefore gaining kinetic energy. When the stone reaches the nail and the board lying on the ground, it does work on the nail, driving it into the board. Having two stones of different masses but on same height above the ground, which one will drive the nail more into the board? What determines how much work the stone is able to do on the nail? It is easy to see that the heavier the stone, the deeper the nail drives into the board, so the heaviest stone do more work on the nail. Here we say that greater the weight, mg of the body, the higher is its gravitational potential energy. But what if we are releasing two stones of same mass but at different height above the ground? Here we find that the higher the stone above the ground drives the nail more in the board, and thus it means it has more gravitational potential energy. We can conclude here that the gravitational potential energy is directly proportional to the weight and to the height of the body away from the reference. The expression then is given by GPE equals to plus or minus mgh, where m represents the mass, g represents the gravitational acceleration, h represents the height, while the SI unit of each is kilogram, meter per second squared, and meter. Note that choosing a reference level is very important to determine the sign of the gravitational potential energy. The reference level of the gravitational potential energy is the horizontal plane in which GPE equals to 0 joules. When does the gravitational potential energy become positive or negative? Consider a group of books that are on shelves above a desk, and the chosen reference where the GPE is 0 is on the desk. Then GPE at the shelves is taken as plus mgh, which is positive, while the gravitational potential energy on the desk is 0, height is 0. What if the books were below the desk on the ground? The gravitational potential energy then is minus mgh, which is negative. Consider this example. A box of mass m equals to 500 grams falls down from point A towards the ground as shown in the adjacent figure. Take the horizontal plane passing through B as the reference for the gravitational potential energy. Calculate at A, B, and C the gravitational potential energy of the system, box, Earth. In this case, we check the position of the box with respect to the reference. Here it is above the reference at point A. So we say gravitational potential energy at A is plus mgha, which is half times 10 times 1 equals to 5 joules. We converted the height 100 centimeters into meters to be 1. Now at point B, what do you think about the height here? It is 0 since it's on the reference. Then GPE at B equals to mghp equals to 0 joules, and it's on the reference. Finally, at point C, it is below the reference. Then the gravitational potential energy at C is minus mghc, and the answer is minus 4.5 joules. Let's solve this application. A ball of mass m, 0.5 kilograms, slides on an inclined plane making 30 degrees with the horizontal without initial speed. Take the reference for gravitational potential energy as the horizontal plane passing through point B. Calculate the gravitational potential energy at points A and B. Starting with point A, it's clear that A is above the reference with a height h. Then the gravitational potential energy at A is mgha, which is positive. But HA is not given. From this triangle, we can say that H equals to the hypotenuse times sine alpha. Then it's AB sine alpha. The expression of the gravitational potential energy at A becomes mgAB sine alpha. After calculation, it is 7.5 joules. Now at B, the gravitational potential energy is 0. Since the height is 0, it is on the reference. This is the end. We can make a comparison between kinetic energy and the gravitational potential energy as a summary. According to the kinetic energy, it is due to motion, while the gravitational potential energy is due to the interaction between the object and Earth. The kinetic energy depends on speed and mass, while the gravitational potential energy depends on weight and the position from the reference. Kinetic energy is always positive. Gravitational potential energy, its sign, depends on the position from the reference. It could be positive or negative or even zero. Kinetic energy equals to half mv squared, while the gravitational potential energy equals to plus or minus the mass times g times h. This is the end of this part. Thank you for watching.